When we discuss descriptive statistics, there are two general concepts that we focus on. First is mathematically determining central tendencies. We do this by establishing the mean, the median, and the mode, which we'll talk about in just a second. That tells us an average. However, accuracy of our measurement is really dependent upon the dispersion or variation of the sample body. If you were to, for instance, determine the average height of your firefighters as 5'9", that tells us a piece of information. But what it doesn't tell us is how much variation within the population there is. For instance, our lowest or shortest firefighter might be 5'4", and our tallest firefighter might be 6'6". And that information can be important. So we measure the dispersion or variation. We do that through standard deviation, variance, and range. Using our example from before, if we wanted to know how tall our firefighters are, we could measure every one of those firefighters, and we could create a graph or some sort of pie chart to show each one of the 75 firefighters. However, that's a bit of information overload. Often we will look for the central tendency, or average, if you will, as a way to organize data so that it's more usable. We do this all the time. We look for the average response time, the average firefighter salary, the average number of injuries per year. It's a convenient way to understand a lot of data in a very concise method. There are three ways we can measure the central tendency. And the one that you're probably most familiar with is the mean, or the statistical mathematical average. You've done this before, I'm sure, in basic math class. The mean is found by simply taking your data set, adding it all together, and then dividing it by the number of data sets there are. In the example below, we have a data set that includes 54, 54, 54, 55, 56, 57, 57, 68, 68, 60, and 60. That totals 623. There's 11 data sets, so we take 623 divided by 11, and we find out that the average age, or the average of the group data set, is 56.6 years. Again, this is a very common methodology, and it's also one of the most useful. If the mean gives us the mathematical average of a data set, then the median finds the absolute numeric middle of a data set. Let's look at our numbers below. Again, the years of service, or years of age of a group of retirees. We see that we have 54, 54, 55, 56, 57, 57, 58, 58, 60, and 60. In that data set, we have 11 observations. So the middle of 11 would be 5.5. By counting over from 5.5, we find that the middle data set, the middle of that numeric grouping, is 5.5 over from the first number, which is essentially 57. The first reported 57. Within that grouping, then, 57 is the median age. If I had 10 data sets, I would split the difference between the two. So the median data set would be between 56 and 57. We use median tendencies quite a lot. When we talk about the median, we may use terms like half of our fire alarms are 3 minutes or more, or half of our firefighters have more than 15 years on the job. What we're determining is what is the halfway mark of our group, and then we compare that half to some statement. The mode is our third variation of identifying central tendencies. However, the mode is different from mean and median in that the first two seek to identify a center point within the data. The mode actually seeks the most common, frequently reported data within a data set. Again, let's look at the age of our retirees. We have a spread between 54 and 60. If we look at the chart to your right, you'll notice that 54 is reported 3 times. It is the most frequently reported age of retirement. It is then, therefore, the mode. We use mode more often than you might realize. When we make statements that most of our responses take 3 minutes or less, we are identifying mode. When we say that most of our firefighters are male, we are reporting a mode, that it is the most frequently reported data within the data set. Anytime you see the word most, you're probably talking about mode.